Welcome to the future of factory automation.
This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM.
Today, we're really getting into the weeds of IoT and factory automation, looking at some of the challenges, the snags, but also some potential solutions that are coming up.
Yeah, we've got some really interesting insights here based on discussions with people who have practical, hands-on experience. We're going to dig into what they found.
We want to explore the real nuts and bolts, things like data collection, which sounds simple but often isn't.
Right, and getting different devices to actually talk to each other, integrating them, and then the network protocols underneath it all, how that works in modern industrial environments.
And for you listening in, if you need to get up to speed quickly but thoroughly on this stuff, we think this deep dive will give you some surprising facts, maybe some aha moments.
Exactly, without it feeling too overwhelming. So, okay, where do we start? What's the first big hurdle they ran into?
Well, one of the first major pain points they discussed was just the cost, really, and the complexity of setting up even basic information collection in these IoT environments.
It's kind of surprising, isn't it? They use the example of wanting to access the current value from a servo motor, just one reading.
Yeah, a servo motor, one of those precise electric motors. You'd think that'd be straightforward.
But it's often not. They explain you might actually need to write specific code, maybe directly on the PLC, the programmable logic controller, the sort of brain on the factory floor.
Right, just to extract that one piece of data from the servo motor's communication area, and then you have to program how to store it so the higher level server systems can even access it.
It really highlights the amount of effort involved just for one single data point. It seems like a lot of work.
It does. And the real frustration, they mentioned, kicks in when you realize mid-process, oh, I actually need this piece of data now.
Yeah. And then you're looking at potentially having to rework the whole setup, right? Go back, rewrite code, redeploy.
Which I think many of us can probably relate to in different contexts. That feeling when the information you need is locked away or just takes ages to get. The cost, both time and money, can be significant.
So building on that, they also talked about the difficulties communicating with those low-level components themselves, like the servo motors we mentioned or remote I/O units.
What are remote I/O units again, just quickly?
They're basically input-output modules, sensors, actuators that aren't directly connected to the main controller but are located somewhere else on the line communicating back.
Gotcha. And getting data from those is tricky too.
Apparently so. They gave the example of trying to retrieve something as simple as a current or voltage reading from one of these remote I/O devices.
And you can almost hear the sigh, can't you? That feeling that these things should be simpler than they are.
Definitely. They described it as cumbersome, requiring quite a bit of effort for what seems basic.
What's the dream scenario then?
Well, the ideal, as they put it, would be to just pull whatever data you need from the higher levels, the servers or SCADA systems, using simple client-side settings, almost plug and play.
But the reality?
The reality, they found, is that many of these low-level components just don't have the necessary interfaces built in, or maybe the underlying mechanisms aren't there to support that kind of easy data retrieval.
So it might be a fundamental design issue.
It could be. They raised the interesting possibility that maybe when devices like servo motors were first designed, retrieving detailed data for external systems just wasn't a primary consideration.
Their main job was motion control, precise movement.
Yeah,
Not necessarily broadcasting their internal state easily.
exactly. And that's kind of an aha moment, isn't it? It helps explain why accessing seemingly basic data can become so involved and, frankly, expensive. It's not always a software issue higher up. Sometimes the hardware itself wasn't built with this kind of data sharing in mind.
Interesting. Okay, what else did they touch on? Power.
Yeah, shifting gears a bit, they brought up power requirements for IoT edge devices, those smaller units out collecting data. They noticed that many of them are primarily DC powered.
DC, like direct current, batteries, or specific power supplies.
Right, and their point was, wouldn't it sometimes be more convenient, especially in certain factory settings, if they supported AC power directly? Just plugging into a standard wall socket.
I can see that. They gave an example, didn't they?
Yeah, like needing to display production data on a regular AC-powered TV monitor on the line. If your IoT device feeding it is DC, you suddenly need converters, extra wiring. It adds complexity.
Sure. Now, they did acknowledge that DC 24V is pretty standard in industrial controls.
Oh, absolutely. It's very common. But they're highlighting specific situations where having an AC option would just simplify the setup quite a bit.
And they noted that maybe the big manufacturers aren't offering many AC-powered IoT controllers.
That was their observation, yeah. Maybe some smaller companies, possibly UK-based, they mentioned, might have them. But the major players seem focused on DC.
They also mentioned IP67 rating briefly.
Right. That's about making devices resistant to dust and water. An IP67 rated device could potentially be deployed without needing a separate protective box or enclosure. Again, aiming for simpler, more flexible installation.
Makes sense. And related to installation, what about connectivity? Wireless versus wired?
Ah, the classic debate. They definitely touched on the challenge of wireless for IoT. There's always that temptation to go wireless, avoid running cables, especially if you need flexibility.
But the trade-off is reliability, isn't it?
Always. And they stress this is particularly crucial when you're dealing with really important data, like quality control information.
Especially with regulations, they mentioned the EU traceability rules.
Exactly. For things like product traceability, data loss is just not acceptable. So while wireless is convenient, you have to weigh that very carefully against the need for rock-solid, dependable data transfer. Sometimes a cable is still the best bet.
Okay, so we've got data access hurdles, component communication issues, power, connectivity. What about emerging technologies? Did they see anything promising?
They did mention the increasing usability of small, versatile devices. They cited something called empiric stack as an example, though they didn't go into deep detail on what that specific tech is.
But it led to a broader point.
Yes, it highlighted this bigger question about different ways to actually do IoT. Are you building these large, sort of centralized infrastructures? Or are you deploying lots of smaller, localized, maybe wireless devices?
And the potential for confusion there.
Right, because both approaches get called IoT, but they're architecturally quite different. It can be confusing if people are talking about IoT without clarifying which model they mean.
So a need for maybe better categorization.
That seemed to be their suggestion, yeah. A more systematic way to classify different IoT architectures could be really helpful as the field keeps growing.
Speaking of technologies, what about single-pair Ethernet, SPE? That was getting a lot of buzz a while back.
It was, and they noted it's still very much being discussed. It's apparently becoming a common direction mentioned in various industrial communication standards. Even IO-Link is talking about it.
So it's still relevant.
Definitely relevant.
Yeah.
But there's a bit of a chicken or the egg situation, they pointed out.
How so?
Well, despite all the talk and standards work, there aren't actually that many SPISI master devices readily available, yet things like hubs or switches you'd connect the end devices to.
So you have the potential end devices, but not enough infrastructure to connect them to easily.
Pretty much. Without that core infrastructure piece, adoption at the device level is naturally going to be slower.
But the potential benefits are still there.
Oh, yeah. The big appeal is simpler cabling, carrying both power and data over just one thin pair of wires. That could potentially overcome some voltage and current limitations you see with standard power over Ethernet, PoE.
So simpler, maybe more capable wiring. Where might we see it adopted first?
Their guess was perhaps initially in higher level systems, rather than directly in every sensor right away. A gradual integration.
But still some uncertainty about how widespread it will become.
Absolutely. It's promising, but the final verdict on widespread adoption is still out.
Okay. Did they mention SCADA systems much?
Only briefly. They admitted not having deep personal experience with SCADA, that's supervisory control and data acquisition systems.
But they shared the general perception.
Yeah, the common view seems to be that SCADA systems are typically quite expensive, but also very powerful and deeply integrated with the production systems themselves. Kind of the top-level view and control layer for many factories.
Got it. So moving from SCADA, what about the communication protocols underneath? That seems like a hot topic. OPC UA versus MQTT.
Huge topic. They highlighted this as a major decision point in the industry right now. A lot of development effort is going into one or the other.
What's the main difference in their view?
Well, they mentioned that many PLC manufacturers are implementing OPC UA servers, which is good for standardization, but it's often seen as a heavier protocol.
Heavier meaning? More resource intensive, more complex?
Kind of both, yeah. Compared to some alternatives, they contrasted it with industrial Ethernet protocols like, say, Ethernet IP.
How does the Ethernet IP differ?
Ethernet IP can be really efficient at packaging and sending large blocks of data together. Think of it like sending a big compressed file.
Okay. And OPC UA,
OPC UA often works more on a request basis for specific data points within its information model, more like asking for individual files one by one.
So maybe less efficient for bulk data.
Potentially, yeah. They suggested OPC UA is generally fine for data updates on the order of, say, once per second. But it can struggle if you need millisecond level data acquisition for really high-speed processes.
Which some applications definitely need. So how does OPC UA address that?
That's the ongoing question. They mentioned the idea of using methods within OPC UA as one possible approach.
And they talk about PubSub too.
Right. Publish, subscribe in OPC UA. They clarified that while PubSub might use faster underlying transport like UDP, it doesn't fundamentally change the fact that you're still typically dealing with individual data transmissions, not necessarily large bulk transfers like some other protocols. It might be faster, but it's the same basic model.
So for high bandwidth, really time-sensitive stuff, maybe industrial Ethernet still has an edge.
That seemed to be their take, especially for things like traceability data where you might need to log a lot of information very quickly. Industrial Ethernet protocols might still be the go-to there.
But OTC UA is still a strong contender elsewhere.
Absolutely, especially for networks where data is collected maybe less frequently, like tracking product history through manufacturing steps. It's very well suited for that kind of structured data exchange.
So the protocol challenge for continuous high-frequency IoT data is still kind of unresolved.
Very much so. It's a key area the industry is working through. And it's not like MQTT is a perfect solution either.
What are the complexities with MQTT?
Well, MQTT requires a central broker to manage messages. And you have to be really careful with managing topics, the names you give to data streams.
Why is topic management so critical?
They give a good example. Imagine you have lots of identical sensors. Each one needs a unique topic name so you know where the data is coming from. If two sensors accidentally use the same topic, their data gets mixed up or overwritten.
Ah, I see. So managing potentially thousands of unique topic names across a factory floor.
It becomes a significant logistical challenge, yeah, making sure everything is named correctly and doesn't clash.
So neither is perfect. The ideal would be.
Well, the ideal would probably be some magical new protocol that combines the strength of both the structure and security features, perhaps closer to OPC UA, but with the lightweight efficiency and maybe easier publish-subscribe model of MQTT.
Sure.
But we're not quite there yet.
Right. Now, they wrapped up with a really interesting point about perspective, didn't they? The PLC engineer's viewpoint.
Yes, this was crucial context. They emphasize that a lot of these discussions and challenges are often seen through the eyes of PLC engineers, the people programming and managing those core industrial controllers.
And their traditional approach is.
Their preference, almost instinctively, is to bring all the necessary data into the PLC first. Centralize it there, process it, control things based on it, all within their domain.
Before sending anything up to higher-level IT systems.
Exactly. It's been the standard way for decades. Collect data locally, manage it in the controller you trust, then maybe pass aggregated or processed information upwards.
How does that contrast with some newer IoT approaches?
Well, some newer solutions kind of bypass the PLC for certain data flows. You might have remote I/O devices or sensors sending data directly to the cloud, maybe using MQTT without the PLC ever touching it.
And PLC engineers are uncomfortable with that.
They expressed a definite sense of unease with that model, this idea of data just flowing straight past their controller to somewhere else. It feels a bit uncontrolled, maybe.
You lose that central aggregation and processing point within the operational technology OT layer.
Precisely. There is a strong desire among OT professionals, they suggested, to process, maybe optimize or filter the data within the controller environment first, before it goes to the IT world or the cloud.
It's about maintaining control and understanding within their sphere of responsibility.
Yeah, they acknowledged it as a kind of characteristic viewpoint of the OT world, shaped by years of practice.
So wrapping it all up, what are the big unresolved questions that listeners should keep in mind?
Well, they really reiterated that fundamental open question. Which communication protocols are actually going to win out in the long run for factory automation and IoT? OPC UA, MQTT, Industrial Ethernet variants, SPE, or something else entirely?
It's still very much in flux.
Very much. And tied directly to that is the other big debate. Is it ultimately better to collect and consolidate everything in a central controller like a PLC before sending it up?
Or is the future trend more towards direct data extraction, pulling information straight from the devices and sensors out on the edge?
Yeah, centralized versus decentralized data flow. Both have pros and cons regarding efficiency, complexity, real-time capability, security. It's a core architectural decision.
And that brings us to the end of this deep dive.
Posting 200 daily episodes. Please follow and comment.
It really leaves you pondering the future of how data will move and be processed in our increasingly automated factories, doesn't it? Will we see a continued momentum towards extracting data directly from every sensor and machine? Or will that more established model of centralized control and data aggregation remain the bedrock of industrial systems? It's fascinating to think about what each of those paths means for things like how well these systems can scale, how secure they are, and our ability to make truly real-time decisions as you continue to explore this incredibly dynamic field.